When you come to class next, we're going to do a lab called mass, and we're going to do a lab and look at a demonstration where we actually weigh and measure the reactants of a reaction and the products of a reaction, and what we'll find is that they're the same, they don't change, which is interesting if you think about a log of wood burning. Okay, so a log is like pretty heavy. After it burns for a few hours, you only have a little bit of light ash left, and you think, well, where did it go? It doesn't, what we ended up with is a lot less than what we started with, but in reality, it's not. If we collected all the gases produced and weighed them as well, what we would find is that the mass before the reaction is actually equal to the mass after the reaction. And that's something called the law of conservation of mass. So the law of conservation of mass states that in any chemical reaction, the total mass of the reactants equals the total mass of the products. So sometimes it's kind of tricky to measure because if something's giving off a gas, we have to account for that mass of the gas being produced as well. And if we weigh it, we'll find out that this is true every single time. So let's look at a couple things. It says, for example, look at the balanced equation. The word balance basically means the number of atoms on the left side of the yield sign equals the number of atoms on the right side. So in this reaction, I have carbon plus oxygen gas gives me carbon dioxide. Carbon is a solid, oxygen gas is a gas, and carbon dioxide is also gas. So the little s means solid, G means gas. And if I look at the number of atoms on the left of the equation will equal the number of atoms on the right. So I got one carbon, I got two oxygens, two oxygens. That's what we call a balanced equation. Next, I'm going to show you an example one that's not balanced. So this equation is not balanced. That's my next one. And the reason it's not balanced is because I have two hydrogens on the left side and only one hydrogen on the right side. I have two chlorines on the left side and only one chlorine on the right side. So it's not balanced. So if the law of conservation of mass were to hold true, the same number of atoms on the left side has to equal the same number on the right side. So we call this, it's a skeleton equation. So we start with two hydrogen atoms in the diatomic hydrogen gas. So hydrogen is a diatomic, that means it has to be H2 gas molecule, and two chlorine atoms, because again, it's also one of these diatomics. So there's 7 diatomics, they kind of make a 7 on the periodic table, and they never exist by themselves, they'll just react with themselves. So you have like H2 and Cl2. We end up with one atom and one chlorine atom together in a hydrogen chloride molecule. This is also known as a skeleton equation. So we call it skeleton equation because we have all the right atoms. We have hydrogen chlorine on this side, and it creates HCl on the right side, except the number of atoms don't match up. So what we do is this thing called balancing, where we put these coefficients, these numbers in front, to make sure that the number of atoms on the left side equals the number of atoms on the right side. So to balance this equation, indicate that 2 HCl molecules are produced. So if we put a 2 in front here, then what we'll have is, all right, we had 2 hydrogens before, now we have 2 hydrogens here. We had 2 chlorines before, now we're going to have 2 chlorines here. So to balance this equation, indicate that 2 HCl molecules are produced by introducing the coefficient 2. So the number in front is called coefficient. We call it that in math class as well, in front of the HCl molecules. So this is our final balanced equation, where when I count, I have 2 hydrogens, and this 2 means there's 2 of these things. It physically means that 2 HCl means I have an HCl and another HCl. The 2 just means whatever comes behind it, I have 2 of them. Okay, so that's what that 2 means. So I have 2 hydrogens, and I have 2 hydrogens on this side. Move this up a little more so you can see what I wrote. I have 2 chlorines, I have 2 chlorines on this side. So that is actually a balanced equation. So the law of conservation of mass basically states that the total mass before the reaction equals the total mass after the reaction. So what that leads us to believe is that the total number of atoms in the reactants equals the total number of atoms in the products. So when I have one of these react with one of these, it actually produces two of these.